December 22 when ChatGPT came. And if we really look at like all the different tech products that have come in the last 10 odd years, then there is a metric called how much time did it take for the product to reach 100 million users. So for Google Translate, it took them 78 days. Then Instagram took 1 month. TikTok took 9 days. Sorry, 9 months. And ChatGPT took only 2 months. So within 2 months, they were able to reach 100 million users and 100 million daily active users. Whereas like the similar feat was achieved by the likes of Google and Instagram in 78 and 30 months. So, well, this does tell that this is a game changer. So we think about a lot of metrics in the field of machine learning and AI, but at the end of the day, customer is the king. If more people are using it, then it proves that yeah, there is something good about that. And that's what ChatGPT ushered in like a new era, I would say. In terms of many people using generative AI models, but not really knowing what is behind it. So that's what I'm going to try cover today. Like, what is the technology that is behind these generative AI models like ChatGPT? And the main thing is large language models. But let's look at some of the other use cases. So when we look at generative AI models, like these are models which can do multiple things. It's not just limited to language generation or image generation. It can do a lot of other things. For example, gene sequencing, music generation, which is considered very creative. In fact, when there was A/B testing which was done where people were asked to differentiate between two samples of music, one which was generated by Hans Zimmer and another which was generated by using generative AI. Like people were hardly able to differentiate like which is what. So that's how good these generative AI models are becoming. And even like for people who are from core engineering, like mechanical engineering, civil engineering, these generative AI models can do 3D modeling, build design, build like blueprints for like machine drawing or whether it is about engineering drawing. So let's try to understand what is the core technology behind these generative AI models. So large language models, I'll also cover like what does it really make them large, but let me just explain what is a language model. So language model is something which understands the language. It could be Hindi, it could be English, depending on which data it is trained upon, based on similar to the way humans do. And these models, when they are trained on terabytes worth of data, uh, then they accumulate a lot of understanding of the language, and that understanding of language is captured in terms of the parameters. So what really makes them large is the number of parameters. And if we look at like there were language models even before LLMs came, but well, they were not really capable. Like they were able to do particular simple tasks like sentiment classification. But when the number of parameters really started running into billions, and the size of these models went into hundreds of GBs, what people realized is they are able to do a lot of things the way humans do. Okay, so for example, it could be text completion, it could be text summarization, question answer, chatbots, writing code, and of course translation as well. So if you look at some of the timeline here, before the language models really came in 2018, there's some new architecture that came, which is called transformer architecture, which came in 2017. Uh, and the title of that paper was "Attention is all you need." So, what like attention as a concept was known since 2014, but then really bringing attention mechanism and along with a very optimized compute architecture was the main theme of this paper. And The architecture that they came up with is today known as transformer, and transformer is the thing that is behind all these large language models. Okay, so I'll come to what is transformer in a while, but let me explain. Okay, what is the language model really doing? So if you look at this sentence, the color of the sky is now for a language model to really predict, like it's what it is really doing. It's doing a prediction. It's not really uh, knowing that yeah, this is the correct answer. It's not a binary thing for a language model. Based on the lot of training data that it has seen, it knows that yeah, color of sky has been mentioned as blue in most of the text that it has looked at. Based on that, it knows that yeah, there's a 91% chance that that blue is the right predicted word at the end of the sentence. So all these language models, what they're really doing is they really do not know the correct answer. What they're doing is they're calculating the probabilities of what words or what sentences should come next, and based on the word or the sentence which has the highest probability, that gets predicted as an output. And when we are using a model like ChatGPT, what we are really seeing is that happening at a very large scale, because like paragraphs worth of content get generated when you really ask a simple question. So they are not just predicting one word, but many sentences and many words at a time. So how is that happening? How is it able to predict so many words or paragraphs? That's where the concept of context window becomes important, which I will cover in some time. But the main thing that I wanted to make everyone understand is these are probabilistic models, and all what they are doing is calculating the probability of the next word or next sentences. Now, suppose you have a language model which has developed an understanding of language, say one language, say English, and now you want to repurpose it for a very specific use case, like say teaching finance. The example that I showed using Vidyaran, there are course related to finance was being demoed. So that entire like course material related to valuation was uploaded to the model, and then it was able to answer things which are from finance, and very descriptive answers with good examples. Now, how is that possible? How is that really happening? Because the language model that we are talking about, people have trained it a lot of text data where there may be concepts of finance, there may not be concepts of finance. Uh, but still, like when we really looked at the answer which was generated, they were, like it looked like that someone is reading from a textbook. So how do we really do that? So that's where the concept of transfer learning becomes important. So, oh, okay. Okay, I'll keep the mouse active then, so that. Yeah. So, yeah, so what I was saying is like a language model may be having an understanding of one language, say English or a Hindi, but with the help of transfer learning, when we expose more data to the model and fine tune it, it develops understanding of that particular subject as well. So, suppose like there is a handbook of related to biology, okay, or like treating people. Suppose if you take all the text data out of that and expose the model to it, it will start talking like a doctor. So that's also possible. And well, people are already doing it. So now, like if you have a language model, say a foundational large language model which has understanding of a particular language, and if you expose it to say, medical data, then it will get sort of tuned to for that specialized task, and then it will give answers, very good answers, by using the medical data which it has been exposed to. So these large language models can be adapted to a particular subject or to a particular topic depending on what data you have exposed it to. So coming back to the transformer architecture, or if we really like try to deep dive, like what's the core element that is I think it's not about sleep. It just disconnects. I'm continuously moving. Maybe there is a loose connection.
सुन कर थोड़ा फुल बैकग्राउंड चाहिए बस मैं भूलना था बस एक्सेप्ट सर फर्स्ट राइट कर स्क्रीन के स्क्रीन डिसीजन स्क्रीन व्यवस्थित नाही म्हटलं
अरे बाबा कोई मैकेनिकल इंजीनियर है बात करो मैंने जब से ऐसे ही चालू
I think in the meantime, if you have any questions, I think let's try to make this session interactive. So please go ahead with your questions. Is there a mic for the audience here? Yeah, I'll just go ahead. Okay, so in terms of these language models and they being able to have a holistic understanding of language, plus having all the transfer learning capabilities, adapting to new type of data. Now, the core element that powers all that is transformer, and that architecture came out in this research paper. Attention is all you need in 2017, and this paper is the one which really changed the field of natural language processing, because earlier when it used to be about predicting text, it used to be only limited to few words. And I'll show you an example around that. So we all have used Gmail, and in Gmail we have seen this feature of auto completion. So if you start typing something, it will start predicting the following words or the following sentences, and you can just press a tab and it will complete. But if you really look at the number of words which it is able to predict, it is limited to maybe a max one sentence or maybe like 5 to 7 words at most. It's not able to predict like the second sentence or the third sentence. So this capability was there even before the transformer architecture came in 2017. And at that time, there was something called recurrent neural networks or RNNs that Google started using. But RNN had its own limitations in terms of it can only predict few words or few sentences ahead. But transformers, because of the parallel processing that they do, they can predict multiple words at the same time. So think of it like you are entering multiple pages of the book into a system, and then the system is reading all the pages at the same time. and on the basis of that, it is again generating some other text, say a summary. Now, when we think of a recurrent neural network, it is like we feed one page, and then it will create some summary. Then you put another page, then again it will create a summary and append to it. So in that case, the processing is serial. So it won't be able to remember all the pages. It will do one summarization of one page at a time, and then sort of create a concatenated summary. But well, that would give you a summary which would look very broken, because what you have really done is summarize one page at a time and then appended it all together. But when it comes to transformers, you can put all the pages at the same time, and then it can create the summary by looking at all the pages in one go. So that is that's the beauty of the transformers, that they can predict, they can consume a lot of data at the same time, and can also make prediction in a parallel way rather than sequential way. So that's where again the concept of context window becomes important. And think of context window as something like memory. Like we as human beings, again, we also process information sequentially. We can't read multiple books at the same time. So suppose someone tells you to, okay, like give a summary of the first, you will go through all the pages. It will take you maybe 2-3 days, and then if you have a very good memory, you will be able to create a summary. But in case of a transformer architecture, if you have created the architecture in such a way that it has more memory, it will be able to like ingest all the text information in one go and memorize it, and then predict the summary. So parallelism and scalability became possible with transformers, but how did it really become possible? Okay, so let's look at that as well. And like if you look at the title of the paper, it says attention is all you need. Okay. So let me first explain how does the text really get represented, because machines or computers would only understand numbers. So when we talk about any text, any words or sentences, you have to convert them into a mathematical representation. Okay. So when it comes to mathematical representation, some of you who are from computer science engineering may know one hot encoding. What it really does is, suppose you have 10 words, you can number them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you can create a binary representation of all these numbers and then feed it to the model. So that would be one way of letting the model know, okay, what word is what in terms of a mathematical representation. But we have thousands of words, and if we look at all the languages, there will be a million of words. So then if you have so many words, then one hot encoding is not really going to work. Even numbering the words in terms of 1, 2, 3, 4 is not going to work. So then what you really have to do is like create a vector space and project the word into that vector space. Now that vector space may have multiple dimensions, and like nowadays, like the vector spaces that these large language models are based upon, they have 4,000 or 8,000 dimensions to it. So one word may be projected into those 8,000 dimensions. So let me try to explain that. Okay, so when we really project a word in form of a vector, words which have similar meaning need to have some association or some similarity. So if you look at the word king and man, both stand for male tense. So if we just try to simplify this and try to understand in 3 dimensions, then king and man, they are lying along the same vector. Similarly, man and woman, they are also lying along the same vector, but they're separated by a distance. Whereas woman and queen, they are falling on the same vector. Like if we draw it from the origin, we'll see queen and woman lying on the same vector. Of course, queen and woman do not mean the same, so that's why we have a space here. So words which are similar in meaning, they would have vectors which would be parallel to each other. They will not be separated by an angular distance. Similarly, like if you look at the verb and like these two verbs related to the word walk, they are also lying along the same vector. So there is no angular separation. Yeah, of course they have different meanings. So they are separated by some distance. So that's how converting a word into vector works. You project it into n dimensions, and words which are similar to in meaning, they will fall along the same vector. There won't be any angular separation, and they would have and the way of measuring that angular separation is in cosine similarity. So they would have a very high cosine similarity. Now, if you really want to do some more mathematics around this, and then we say, okay, man minus woman plus queen. So what you are doing is okay, like you are saying okay, like first, so if you look at the word queen and if you want to transform it into the word king, then we need to add man to it and subtract woman from it. Then the word king will come. But how would we do that in the mathematical in a mathematical way? So well, that is what becomes possible by converting these words into vectors into n dimensions. So there is one more mapping here. So Spain and Madrid, because Spain is Madrid is the capital of Spain. So in the vector space, they will appear closer to each other. Similarly, Italy and Rome, India and Delhi, they will appear closer to each other. And now one may ask, okay, like how is the model really learning that yeah, these two words are similar in meaning, or these two words are correlated to each other? So think about a child, like kid, like a toddler. Like they learn things by observing them again and again. If you tell the toddler that yeah, this is a ball and you have to throw it, okay, and like sometimes we don't even have to tell them, okay, like they see other kids throwing the ball and they also start doing the same thing, kicking and throwing the ball. So similarly, like when it comes to a machine learning model, you expose a lot of data and lot of text, and in that text it would have seen that yeah, Spain and Madrid are appearing many times together in the same sentence. So Spain is the capital. Madrid is the capital of Spain. Madrid is the biggest city of Spain. Madrid is where the government of Spain sits. So it would have seen so many such sentences where Madrid and Spain would have appeared together. So from that the model learns that yeah, these two words are in some way related to each other. Now, if we really expose the model to text or data which says something altogether different, then the model is going to end up learning that. So the data is the king here. If you expose the model to the right data, then it will learn the right things the way we know them. But if you will expose it to factually incorrect information, then yeah, which it would make like completely wrong associations and would have a wrong understanding of language. So till 2017, before the transformer architecture came, uh, like this like word being converted into mathematical representation, that was there. So that basic building block where you can represent word in the form text in the form of mathematics or vector was there, but the main limitation was context or limited memory. Well, that got solved by this transformer architecture, but it did one more thing. The other thing it did is it started like learning the association between words by looking at the sentences in which those words are being used. So if you look at this sentence, these two sentences, the girl and the boy walked home, and then it is followed by later Elias came up to Bob. So these are like sentences which come one after the other. Now, if you really want a way to know that the word she is in some way associated with the word girl in the following sentence, then we would learn one more aspect of this particular pronoun that this word she is actually highly correlated with the word girl. Similarly, like the word he would be correlated with the word boy, and the name Bob would be correlated with the word he as well as there's no him, right? So the word he would be associated with Bob, the word she would be associated with allies. Now, these are different words, but they do not have any similar meaning. Like she and the name of the girl, he and the name of the boy. Well, there's no vector similarity, or as such, like there's no cosine similarity in these words. There is a clear angular separation because one is a name, one is a noun, and other is a pronoun. So how would they end up lying along the same vector? That's not possible. But that became possible with this transformer architecture and the concept of attention, where words which are referring to each other, like to the neighboring words in the neighboring sentences, the model actually builds a association map, and that association map is what we know as attention. So one was okay, like knowing the words in terms of their literal meaning, and another is knowing the meaning of the words within the context of the surrounding words. That became possible with this attention mechanism. I will give one more example. Like the word bank, robber robbed the bank. Here it means financial institution. Whereas I swam across the river bank, same word. Here it means altogether different. But when we just talk about word as vectors, the word bank means the same thing. There are no two separate vectors for the word bank. But when we bring in the attention mechanism here, which was a contribution of this paper, attention is all you need, then you can start understanding the meaning of the words in the context of the sentence or the neighboring text. So that, and exactly that's how human beings also learn or interpret language. Okay, like when someone is talking, like, and we try to understand it holistically by connecting all the sentences and all the things that they said. We just don't look at the words alone. Now, to really make that possible for language models, we need to bring in the attention mechanism, which is a part of transformer, and transformer is like the backbone of these large language models. So I'll now take a pause, okay, like to see if there are any questions, because we have covered a lot of theory so far, and I'll pause at this slide. In the meantime, I'll play one animation so that. What we are seeing here is like as the number of parameters increase for these large language models, the number of things, the number of tasks that they can do also multiply. So with 8 billion parameters, it was only able to do arithmetic, QA, language understanding, but with 300 or 400 billion parameters, it can now do much more things. And many more things which sometimes, like, we as human beings also struggle. Like, we won't be able to translate languages, but it can do arithmetic, it can do language translation, it can write code, it can do so many things. If there are no questions, then I think we should switch gears and maybe do an exercise now. And like to really do the exercise, I think there was a exercise material that was shared with all the participants. So yeah, means if you have already followed those first four steps, we'll start with the exercise, and then again we'll try to go back to the theory.
किती झाले खूपच स्लो आहे कोणाचं ते काळावालं कोणाचं ते काढून टाका ना हे काळावालं तुमच्या लागला MBA मॅडम तुमचं नाव नाही माहिती म्हणून मी MBA मॅडम मी विचारलं पण नाही
So, is everyone able to load this page and come to this portal perplexity.ai?
सेशन खत्म हो गया जाने का टाइम आएगा कहीं भी रह जाओ
So this was the exercise material that we shared. Yeah. So just go to this portal, perplexity.ai. Then click on the sign up. So you'll have to put your email ID. And once we have done that, then you will be able to get started with the Excel. You can sign up using Google or you can just put your email ID. And once you have done the sign up, then you will be able to come back to this page once again.
परप्लेक्सिटी ChatGPT
Everyone able to sign up.
अपडेटेड आहे का नाही बघशील चांगला आहे परप्लेक्सिटी ChatGPT
This is also sign up page would appear.
वाढला कॉम्पिटिशन होतं परप्लेक्सिटी माईक बंद केलं
If you have signed up and you're able to log in, like the way the page would appear is it will you'll see your email ID or something appearing here after you have signed up. Now, so it gives you multiple functionalities. Like one is you can ask a question about say you asked about elections in India. I think that's the hottest topic these days. So yeah, it tells about the elections that happened in the past, and it also tells about the elections which are happening in 24. It also gives you some recommendations on like what other questions that you can ask. But well, all this it is doing based on the training data that or the text data that it has looked at. Suppose you have another use case in mind where you want to chat with a particular document, say a book. Okay. Um, so I'm going to upload a book here, a chapter from an NCRT book. You can upload any book, any PDF that you have in your system. Yeah, let me upload this about that one of the technical conclaves, okay, which happened in one of the educational institutes. Here is the NCRT. So let me upload one of the smallest chapter that we have here. So right now it's uploading that document. Let me also open okay, what that book is, chapter is about. It's a PDF which is 2 MB large. So map of India, okay. And it is about prehistoric rock painting. NCRT book downloaded from the NCRT website. Now we have uploaded this book chapter. It's open source, anyone can download an NCRT book. Now the questions that we are going to ask are going to be based on this book chapter. And let's see if it is able to answer from this book chapter or not. I saw a mention of Bhimbetka in this chapter. I'm just typing it. So it gives the answer. Let's try to see, okay, like if it picks how much of this text is actually picked from this book. And you can pick any other document of your own choice. Here is that chapter. Let me do a search about. So I think yeah, means there's a lot of text around Gimbitka which is there.
प्रॉब्लेम आला तर फोनचं अनलॉक आहे 401 कोणाचाही फोन आला उचलू नका साहेब चहा पिता
Bhimbetka is mentioned in multiple places. It says there are 20 layers of paintings, and it is located 45 kilometers from Bhopal. Let's see what the answer is. So it says yeah, like it was discovered by this archaeologist, and it has around 800 rock shelters. Uh, so what it did is like it right now it is looking at the text which is there in this book plus the text related to Bhimbetka which is available in its own training data, and based on that it is giving us an answer. And now it is also, like it's also giving us some recommendations. Like these are the other questions that you can ask. So let me say that okay, tell me some important insights from this chapter or from this document. What it really did is it looked at this particular paragraph and in like the previous answer, and rather than giving us the insights from the document that we uploaded, it gave us the insights from this answer itself. Now one may think, okay, why is it doing? So how these large language models work is when you are doing a chat with them, doing a question and answer, the previous question and answer also gets appended to them, and whatever is the most recent data that they have predicted or generated, they use that also to answer the following questions. So that's why what you are seeing is yeah, it has answered few other things from the chapter, but most of the things that it is giving in this answer are related to Bhimbetka only. Okay, let's try asking one more question. Who's the author of the document? Well, in the book chapter, like there's no clear mention of who is the author of this book or who is the author of this chapter. As we can see, nowhere they have mentioned what's the name of the author. So yeah, it's saying accordingly that yeah, the document does not strictly states the author. Okay, it appears to be taken from a textbook. Okay. Let's all tell me some important questions. Okay, now I asked, okay, like, tell me some important facts from this chapter. So it gives me a nice summary in the form of bullet points. Uh, it talks about prehistoric paintings, then where all they are located, about the rock shelters, uh, where all they are located in different states. So it gives us a summary of that. So now think of your role as an educator, and suppose you want to create some question and answer for evaluation, and you have a lot of text material in the form of your course handout or lecture material or slides, and you want to create questions around that. Then this could be one of like this is where generative AI can help you. So is everyone able to access this and try this? Okay. So now we'll look at one other platform.
इसको लॉगिन में नहीं लगता परप्लेक्सिटी आ गया इसको इमेज भी अटैच कर सकते हैं This guy is Indian.
College internet is blocking this program.
So doesn't complex it.
I don't think I'm on your right. That's not connected. So this is the same platform around which that demo was shown by that student. So uh, let's try to create a course here. We looked at one of the use cases where we can chat with a chapter or a book. Now, suppose you as an educator, you want to onboard a course and provide that conversational learning experience to your students. Try to I mean, if you are able to open it on your, please try to open this. I had to connect to my hotspot because it was getting blocked. So let me try to create a course. I'm just giving it some name. Then I'm going to go and select chapters of that art course NCRT book. This one and this one. You can select as many as five as you want. So right now it's uploading. And these files can be in any format. It could be Word, it can be Excel file, it can be TXT, PDF. So well, all these files are buffered now. Now we'll click on upload your files. So it is telling that yeah, this particular PDF has been uploaded. Now it is saying onboarding course. Now it is onboarding the course so that you can really chat with it. Now when we say we are onboarding the course, what is it that is really happening at the back end? I spoke about all that word being converted into vectors and the meaning of words being understood in the context of words which are in its vicinity. All that is happening right now. We are converting the text into mathematical representation and storing it into something called vector database. Now, this is a process which takes a while. In the meantime, this is happening. Let me go to this. So, suppose like what we did is like we onboarded a course related to principles of management, and we asked okay, like create some questions around Maslow's principle. Now, the way it is working right now is when we asked about Maslow's principle and we said, okay, like create some questions. The earlier application that I showed you in Perplexity, it would have, whether you upload something or not, and you ask it the question, it will still answer. But here, with this platform, Vidyanand, what's happening is, suppose you onboarded a course, it will only look at the vector database corresponding to that course and then respond to the questions. Now, what it really, the way it really helps, one is that yeah, maybe there are things, similar things which are available on Google search, which are not factually correct, and you don't really want your model or generative AI model to be answering things based on that information. Now, with this type of platform, you can ground your answer in the course content that you have. So one is, of course, you can create questions. Suppose you want to identify like some of the important topics. So it will it helps you lift down them as well. Suppose a new textbook came, the course material changed, some of the chapters got revived, and you want to create a new handout. I remember that during my engineering days, we were given a printed course handout in the first class of the course. So that handout will contain, okay, like these are the chapters, and from these chapters, these are the important topics that are going to be covered. So, well, textbooks keep getting revised all the time, and you have to do this exercise. Then generative AI can help you there. It can sort of, yeah, automate that entire thing for you. Suppose we want to create assignments, fill in the blanks. We can ask it, okay, like create fill in the blanks around this topic. So it's going to do that as well for you. Well, I have not put in the next question in the slides like that fill these blanks. It does that also, and when it is doing that, whenever it is creating all these fill in the blanks and giving the answer, it is only looking at the material that you have uploaded. It's not looking at anything which is available over the web. So let's see, like if that course has been onboarded now. Okay, it seems that it did get on board. Yeah, see, it says, yeah, select action course chats, or yeah, I guess the course has been onboarded. Yeah, see, it says you are all set to chat with your course. So now we'll go and select course chat. And from the drop down, we are going to select the course. Uh, there is one more feature that you have here, like the type of prompt. I'll cover what do I really mean by prompt in a while. But let's see, like let's chat with this course. Okay, so it tells okay that from the provided document, like these are some of the important topics. So we use the restrictive prompt. Okay. Now let's select the different prompt called relaxed prompt, and we'll ask the same question. So you change the prompt, and the way the answer is coming out that also gets changed, and it also tells us okay that the name of the book, okay, and it says that this book is for class 11th and class 12th, whereas this information was not really there in this answer with a restricted prompt. So think of prompt as an instruction. What you are telling the large language, like the generative AI model, is that with the relaxed prompt, you're telling the language model that you are free, okay, to be creative and accordingly predict the words and give us a good quality answer. But with the restrictive prompt, there was not much of a liberty for the model to predict words. It was only able to predict words which had a very high probability. It was not able to predict words which had a low probability. But when you relaxed that instruction, we got a more creative answer which is also more descriptive and really well formatted. Now let's try the third prompt, which is creative prompt. So I think it did change the answer. The look and feel is very similar, uh, but not much changed here. Okay, let's try asking some more questions. But before we do that, okay, like let me go back again to this slide. So we onboarded the course in real time. I think those two chapters got onboarded in 5 minutes. I think it took around 5 minutes, and then we started asking questions. And the answers that were coming in also very quite quick. Okay, so we what the students who built this platform also did is to like do a time study and see like what's the average response time. So the average response time is around 4 seconds, and even if we compare it with ChatGPT, it comes really close to the response time of ChatGPT. Another thing, it gives good answers, and the response time is also low. But then, is there a cost involved? Yes, of course, there's a cost involved because you're running a generative AI model, and it requires a lot of compute. Okay, I talked about billions of parameters and the size of the models. These models, uh, the size of these models is sometimes in hundreds of GBs. So even to just load the model, you need to have a RAM which is that huge. Generally, we work with systems which may have up to 32 or 64 GB RAM, but here we are talking about hundreds of GBs of model size. So if you really want to just load the model into your system and then be able to do anything with it, you really need to have a very good compute capacity. You need to have GPUs. So with the limited, with some of the limited things, limited compute that was used to build this application, what we found is like the cost per question is around 4 paisa, 4.5 paisa. Okay, so if we really convert it into, okay, say a student is asking say 24 questions in a day, multiplied that by 30 days in a month, so the cost will come out to be rupees 30 per month per student. So, well, like we are able to get these type of answers and with a low response time, and the cost is also not very high. Like a textbook itself, if you want to go and take a Xerox of a textbook, which has 100 pages, it will take you at least 50 rupees. It is much cheaper than that. And with all the added features where you don't have to read through the book, you can chat with the book. So I'll stop here. Like I think I've covered, I've done one. We have done so far. We have done one exercise. I also gave this. We also created a new course. We try to chat with the course. There are other courses as well. Okay. Let me give an instruction. Okay, that translate the above in Hindi. It gives you an answer which is not just in Hindi, but it's in Devanagari script. Let's try, okay, let's try it. Ask it that translate the in Marathi. No, now it is really going to take some more time because Hindi, English, some of these languages, these models are really good at. But let's see like how good it is in Marathi. I can read this, but I won't be able to know if it is completely accurate or not. But I will leave it for the audience here to find out if this is really making some sense. Here is the Hindi answer, and then here is the Marathi answer. You can compare.
जान पे बैठ के
So we asked the same question first in English. We did not give any language. Okay, like we asked it in English, so it responded in English. Then we told it to translate it Hindi. It translated the answer in Hindi. Then we said, okay, translate it in Marathi. Now it has translated. Let's try one more language.
हे भाई रिटर्न तो होते pyramid of life and security
No, Telugu I don't know at all. Telugu koncham koncham. That's all what I know. Yeah, we'll try to see if it is really doing a good job or not. It answers in Telugu. I can't read it. Sorry for that. But I think so that this is Telugu. So well, what it unlocks for like the education field is like you may have students from so many different languages. They may or may not know English or some other common languages like Hindi, but they most of the people do know their mother tongue. And yeah, means if you go to remote areas or villages, vernacular languages are the ones which everyone knows, but English people may not know. So now, if you want to really take the education and knowledge to them, then well, generative AI can help you do that. Is this a good answer? This is okay. So, well, this anti-generative AI model is using a large language model that is coming from OpenAI. Of course, a commercial large language model, and there is cost involved to that. And when you really do the arithmetic, then the cost comes around 4 paisa per question. If the answer is very small, then it may be like 1 paisa or 2 paisa. If the answer is lengthy, 1 page or 2 page long, then you end up spending maybe say 6 7 paisa. So depending on the length of the answer, you made a question. I just want to clear this screen. A lot of answers have got accumulated, so let me just reload the page. So again, go to course chat. Then I'll select using the drop down. There are a lot of courses that have been onboarded. Yes, this is the name of the course. And we saw that yeah, with the relaxed prompt, the answers are better actually. So we'll go with the relaxed prompt only. It does. So it clearly lists down okay that these are the objectives. It tells okay that yeah like this is a book okay related to introduction to Indian art. We have done an MCS with these following objectives and outcomes. And then it says okay like here are the key points around that. Well, one would have to really read the book and see okay like if it is really capturing everything. But on a high level it does seem that yeah it is capturing all these things. So if you also want to use this application and try to do a hands-on exercise, we can maybe do it after you know just a break.
वही है कि दूसरा है वही है कि दूसरा है
So well, you'll have to create an account, log in. Like the link is there. All can go and open the link, try opening the link. You'll have to create a login, and then once you're able to log in, then yeah, you can start playing with it. Uh, like any other questions that audience wants to me to really try and see like what is able to answer that. Let's see like okay, let's read some fill in the blanks. It does create some fill in the blanks. Okay, let me ask. Okay, uh, this is history book, so pretty difficult. But yeah, we can try some other course like finance course. But let's see. Okay, like give the please fill in the blanks. When you're talking it like in a human language, you don't have to write any code. Uh, it fills in the blank, and I think the answers are in bold here. You can clearly see something. It has changed the font. So this is an art book, so you can't really ask analytical things. But let's try some finance course like valuation, where yeah, mathematics is also there. Okay. So let's try some finance related course. Finance is like 50% math and then 50% theory. And advanced finance is more about it starts looking like calculus. Okay, now we have selected the course and we select the relaxed prompt. I'm not sure, okay, like how many of you are from finance, but in finance, when we talk about, I think net present value is something many of you would know because we all invest our money, and whenever we look at any investment option, we say, okay, that what is the yield it is going to give me in the next 5 years or 10 years. So suppose you invest 1,000 rupees every month, so 12,000 rupees in a year, and then you'll say, okay, at the end of the 5 years, how much money and principal and interest I'm going to get. Same is the case with companies. Like when you talk about valuing the companies, you look at okay how much revenue they are making every year, and then uh, you just don't add the revenue. You have to sort of adjust the revenue value depending on the inflation as well. So that approach is called DCF or discounted cash flow. So let's ask, okay, like any question that comes to your mind. This is a mix of analytical and like theoretical question. Let's see if it is able to answer. So when the answer is actually coming, it is only looking at the finance content that it has been exposed to. I spoke about transfer learning and adapting the model. So that's what is really working here. When we expose this model to, when we expose the large language model to this particular content, uh, it started it made that also a part of its understanding, and basis that augmented understanding, now it is able to respond to the questions. So well, it gives you like a very well formatted answer in the form of 7 bullet points. Okay, that you need to do cost management, you need to look at the revenue growth, you have to do profitability analysis, cash flow management, innovation, forecasting. It tells you a lot of things. So now let's ask a follow-up question. Now, where shall I get the funding from? Well, here I'm not saying that okay, I'm the CEO of a young company. I'm not saying any of that in the question. I'm just saying okay, where shall I get funding from? So this is the way we converse. Like we don't have to give the context to the person in front of us every time. And if you really look at the length of these answers, like these are 500 to 1000 words long. But if you really compare that with like the autocomplete feature in Gmail, it can hardly do like 5 to 8 words or maybe a sentence at most. But here it is generating well formatted text, which is 500 words or 1000 words long. Again, it gives you the answer in the form of bullet points. It says, okay, you can do bootstrapping, you can raise money from friends, you can go to angel investors, venture capital, crowdfunding. It tells you all those different options that you can look at. Even government funding and when reaching out to incubators. So let me ask one more question. How do I allocate? Generally, when like these startups, what they do is because they do not have a lot of, they are not profitable. So rather than giving salaries to the employees, they give them some shares. Okay. So let's ask a follow-up question: how do I allocate equity to the employees? So again, it gives you yeah, well formatted answer. It's just you can give it in terms of stock options, RSUs, and so on and so forth. So again, if you look at the way I asked this question, I'm saying how do I allocate equity? Now, it is able to like whereas I here refers to this thing which I asked in the first question, CEO of a young company. But I'm still able to associate in the forward question that by I mean CEO of a young company, okay, which has this type of situation. So it is paying attention to the text that we have provided, even which was like 4 or 5 questions back. So that's where the attention mechanism starts playing a huge role. It is not just looking at the words, it is also paying attention to okay, like this word I is actually associated with the CEO of a young company which has positive revenue and negative profit. So that's what attention mechanism is doing. Whereas if you just look at word similarity, I would mean nothing. So that's how this attention mechanism, which is part of these large language models, helps in generating text which is meaningful. So I was talking about all these things like that yeah we have this transformer architecture and it has got words in the form of mathematical representation plus there is attention. So I really demonstrated that how that thing really works when we are interacting with these models. So let's look at some other concepts. So I think attention would have become clear to all of you by now, and why we have to convert words into vectors would have also become clear to you. But still, if there are questions, I'm happy to take questions. If you're more curious to know like what is this transformer architecture, what does it really look like, there is a lot that's happening there. So there is a neural network which is sitting here. So this is the encoder block and this is the decoder block. Here there is a feed-forward neural network. Similarly, the decoder also there is a feed-forward neural network. Then a lot of matrix multiplications that happen here. If you break this multi-head attention further, then you will see all these matrix multiplications, concatenation, linearization happening here. If you break this scale dot product thing again further, you will see all these matrix multiplication operations happening. So I don't want to really get into the mathematics of it, but I think by now it would have become clear, okay, like what is attention, how are the words being understood when we are converting them to vectors, and all that which is helping us do that is this particular architecture. So if say someone really asks you, okay, like what is it that really is powering generative AI, you can with confidence say transformer architecture. So I also covered that yeah, like before the transformer architecture really came, people were using recurrent neural networks, LFT, which had a limited memory. So they won't be able to look at a lot of text and then be able to respond basis that. Uh, and I showed this example, like Gmail when it does auto completion, even today when they are doing this auto completion, it is not able to do it for more than a sentence. But when I was asking those questions, I was just asking the question in one line. Sometimes I was using pronouns which were referring to something that was described or explained 4 or 5 questions back. Still, it was able to generate thorough answers. So that is what is the difference in regular natural language processing and large language models. This is regular natural language processing. Like it can predict maybe 4 or 5 words or a sentence at most. And even in those times, 2014, 2015, it was able to predict few words, but the prediction quality was poor. Okay, and it would not really understand the complexities of language. And when I say that, it means like understanding the meaning of different words based on the context. That was missing altogether till the transformer architecture came. Going back to the timeline that I showed here, so first came transformer and then started coming some language models like BERT. Okay, BERT was again from Google and it came in 2018. So BERT stands for bidirectional encoder representations from transformers. It is also using transformers, but in transformer architecture, I showed that there is an encoder block and there is a decoder block. BERT uses only encoder block. There is no decoder block. So now what they introduced are these two important concepts which improve the understanding of language. In fact, uh, this paper really showed the world the way how should people train models based on text data. So it came up with two concepts. One is the vast language modeling, and the other is next sentence prediction. So let's look at what does that really mean. So in terms of next token or word prediction, we may have what we can really do is okay, like we may have a chapter where there are so many sentences. We would deliberately mask some of the words which are coming appearing towards the end of the sentence, and then we are forcing the model to now predict the word. So in the training, while it was scanning all that text, it would have seen that yeah, Hana is appearing in most of the sentences maybe as a sister. Okay, so when you really force the model to predict, it would pick the first option and say Hana is a sister rather than the other three options. Okay, so another example. Okay, so like what I have done here is okay, Jacob dash reading. I have masked this word, but in my training data, I know what is the real word here. So the answer to this blank is no. Now we are forcing the model to predict that word. And when we force the model to predict that word, what we are trying to do is we are calculating the probabilities of different words. And what we want the model to do is that it should assign the highest probability to the correct word. So in this way, what you can do is you can mask a lot of words from a lot of sentences, and then you force the model to predict. So your text data now becomes your training data. Okay, and in that way, what the researchers found out is the model started developing an understanding of the language by by removing some of the words and then forcing the model to predict those. Now you really don't need a training data here. You can always pass some words and then force the model to predict that. So that thing becomes your training data. So that was one. Another was next sentence prediction. So here in place of masking just one word in the middle of the from the middle of the sentence, you must mask the next sentence altogether, and then you force the model to predict the next sentence. So you have your text, okay, which may be like a chapter from a book, and in that from that chapter of the book, you take away some of the sentences, you hide some of the sentences, and then you force the model to predict the sentences. You already know the right answer. And when you are forcing the model to predict that sentence in an accurate way, what you're trying to do is you're trying to reduce that loss function. And in that, what these people observed is in that is another way in which you can force the model to understand natural language. So these are like the two important concepts that this paper brought up: next sentence prediction and vast language modeling. And with that, what people realized, like what they found out is the model, the language model, the word model which they built, had a good understanding of English language. Another animation at play, so like the word da and cooked are masked here. You remove these two words. So it is able to predict this, that after this, here it is able to predict this word correctly. The word cooked, it is able to predict, but the other word it is not able to predict properly. So 2018 it was only about some language models like BERT, which were of the size close to 1 GB, 800 or 900 megabyte. But fast forward 2 years, other language models started becoming popular, and traditionally the transformer architecture, as I showed, consists of both the encoder and the decoder. This is the encoder and this is the decoder. But it was only this encoder part, it did not have any decoder. Traditionally, the encoder, like transformers have an encoder decoder architecture, but in another 2 years, this group of researchers from OpenAI, what they found is they really don't need an encoder. Decoder alone is sufficient enough because if you look at the architecture of encoder and decoder, there are multiple components which are similar. So you can recycle the same architecture and you need not have a separate encoder. And these GPT models, which have come from OpenAI, like GPT-3, 3.5, GPT-4, and they're saying, okay, GPT-5 will also come by the end of this year. They only consist of decoder. Okay. And again, these decoder have the transformer architecture. And transformer architecture makes use of attention mechanism as well as neural networks. Okay. So, like if you really look at these language models, the first thing that comes to our mind is okay, transformer. If we talk about transformers, then it's about transformer is a hybrid between neural networks and attention mechanism. Okay, and the new set of these like large language models like GPT, they do not have both the encoder and decoder. They only have the decoder. Okay, like there are different architectures. Some LLMs only have encoders, some have only decoders, some have both. But where to use which architecture? So what people have found is like if you want to do a language translation type of job, then LLMs which have an encoder decoder architecture like BART. Okay, this is a model from Facebook. That is good. Whereas if you want to do sentiment classification, language understanding, encoder architecture is good enough. If you want to do text completion, uh, chatbots, QA, then decoder architecture built LLMs are good enough. So, well, there were language models which were there even in 2018 and 2019, but then what really changed? And like the current state, like we saw that we were able to generate very thorough answers, very well formatted answers, and which were factually grounded in the course material that we have had. So how is all that becoming possible? So as I said that earlier, the size of these models was hardly like a GB. That's it. Because the number of parameters is also like a million parameters. But when that number of parameters became 10x, we saw the accuracy went up. Okay, like 5% became say 18%, and when you increased it by another 10 times, the accuracy did not become 10 times, but like uh, it came close to around 65%, 70%. And with these models like GPT-4, we still don't know how many number of parameters they have. Some people say 500 million parameters. The accuracy is around 80%, 90%. So that's what happens when you try to increase the number of parameters. And what really dictates okay the number of parameters? What really dictates the number of parameters is how much training data have you exposed the model to. So think of these parameters as like the neurons in your brain. And of course, we do have neurons, but when we really learn something, what happens is there are interconnections which happen among the neurons, and that's when something really gets stored, okay, or absorbed in our minds. So similarly, like when we are exposing more data to these models, that data gets stored in the form of these parameters, and the higher the number of parameters, the better these models become at understanding things. So what I said is like yeah, means if you increase the number of parameters, the accuracy goes up. Well, that's a proven fact, okay, but is that the only thing? Suppose if I make the number of parameters to be say 1 tera wide, like right now it is 175 billion, okay, so say I say 1000 billion parameters, will the accuracy become 100%? Or will it not? Where will it land up? Well, this is something people are still looking at, but in the meanwhile, people were, while they are doing all these studies, what they also found is that it's not just about how much training data that you expose to. It's also about like how do you train the model. So think of this as there like you may have a very good library in a school, but you may not have any good teachers. Then will the students really perform well or not? Without any guidance, without any teaching, without any training. Nowadays, like these books, NCRT books, lot of engineering college-based books, they're available open source. Like you can go and download them. But does that really make the life of a teacher or a professor any way easy? No, still training needs to happen. So same is the case with these language models as well. It's not just about how much data or how many number of parameters. It's also about how do you train these models. So what people observed is uh, when you rate these answers on a scale of 1 to 5, where 5 is excellent and 1 is bad, uh, just by increasing the number of parameters, the human rating of the answer does not really go up. When I say human rating, that answer may be factually correct, but we are asking someone to give it a score, okay, on a scale of 1 to 5. 5 being excellent, 1 being bad. You increase the number of parameters, you increase the training data that you expose to, the score, the Likert score did not increase much. It went from 2 to maybe 2.2. So I think this is 2.2 and it may have went to 2.3, 2.4.
तो the hotspot शुरू है क्या?
But when you started
इसका तो
prompting or giving good instructions to the model, and you also increase the number of parameters, then the quality of the answers based on human rating, it went up significantly. Even if you look at in these two cases, like the number of parameters is the same, so volume of training data is same. But here, without any proper prompting or without any proper instructions, the quality of answer is around 2.3. But here it is close to 3. And in fact, here without any increase in the number of parameters, the quality of answer has went up to 3.5. And then came this new paper, which uh, which became very popular. They called it Instruct GPT. So where they were actually giving some instruction to the language model that okay, like if this is the question, then this is how you should answer it. So they started adding some instructions to the model. So what with that, what they observed is that the human rating of answer went from 2 to close to 5. Same amount of training data, but the same training data along with some set of instructions to the language model, the quality of answer goes up without increasing the number of parameters. So in the previous slide, I was talking about okay, like how do you improve the accuracy of these models? Increase the number of parameters. Now I'm saying okay, how do you improve the quality of these answers? For that, you have to have a better training. Okay, so both the things are important, not just the volume of data or the number of parameters, but how do you train these models, that is also important. So, if you look at the last 5 years, so when BERT came in 2018, it had 340 million parameters. So I remember when I was using it in 2017-18, it used to be 800 MB file. Means it used to look very large to me at that point of time. That yeah, it's 800 MB file and I have got 4 GB RAM. Uh, it used to hang my laptop. GPT-2 came in 2019. It had 1.5 billion parameters. Again, no big deal. Close to a GB or 1.5 GB space it would take. But now, like since then, like there has been continuous increase in the number of parameters, and now people like these commercial LLMs, they're not even telling how many parameters there are. They're not even telling what's the architecture. So, for PALM model that is from Google, which is again open source and it is known in public open domains, that it has got 512 million parameters. And if you want to download that model, you'll have to spend like you need to have very good internet speed, and you should have a lot of storage because that model itself may be 50 to 60 GB in size. So hard disk space that it is taking to take is around 50 to 60 GB. Like when you want to do inferencing, think of the RAM that you need, and that's where the importance of GPUs become. because GPUs come with a different type of computer architecture, and they can you need GPUs to actually handle these large language models. And in fact, in the last 4 years, there has been an observation that every 3.5 months, the size of the language models have almost doubled. And another thing by that, 2013 was the time where these word to vectors came, like representing word in the form of mathematical vectors. Then came RNNs, recurrent neural networks in 2014, and people started using them in Gmail for auto completion. Attention mechanism came in 2015, but transformers came in 2017. And with once transformers came in, then started coming all these large language models, which are using sometimes encoder or both encoder decoder or just decoder architecture. So these are some of the language models, and the ones which are highlighted in yellow here are the open source ones. So there are more open source language models than the commercial ones. If you want to use them, it's free of cost, but what you really need is a good compute, some GPUs. And these LLMs have come from all the different places in the world, even like whether it's American big tech companies or some other like countries like Europe. A lot of these companies are building these models. Some of them are open source, some of them are commercial. Which by commercial I mean you have to pay pay a bill, okay, to use them.
The structure open केला.
And yeah, then comes this particularity that yeah, like, as the number of parameters increase, you can start doing a lot more things. So recently there was a study done by some of the professors in IITs, and what they found is if you give these GPT models JE paper to solve, they do a fair job. Okay? And by fair job, what I mean is it was able to like in terms of all the physics, chemistry, and maths question, uh, these GPT models were able to come into a 95 percentile rank. So they were better than 95% of the students who have appeared in JEE. So, so this is what GPT model was able to do. But is that really good enough? Can a GPT model qualify a JEE exam with 95 percentile score? The answer is no. Means most of the students who get into JEE, who get into IITs through JEE, they have a score of more than 98 percentile. So yeah, means these models are good, still far away from really cracking the JEE exam. People have reported that yeah, they can write the SAT exam which happens in US, and it is able to clear the American law exam. But still, I think JEE paper is one of the toughest. Okay, it's still not good enough to solve a JEE paper and like get a qualifying score. But well, as the number of parameters are increasing, as these models are being trained with more data, with better training instructions, we really don't know what all they would be able to do. Okay. So today we are seeing okay like this tree stops growing at a particular place, but maybe it would start doing other things like maybe writing joke, uh, creating movie scripts. Uh, maybe that I think that time is not very far away. So before we go further into more use cases and some like two other important concepts, like I'll just stop here like to see like if there are any questions, whether from the exercise or or the that Vidya platform that I showed.
Follow? Like on? Question. Like.
Sir, there is one question. You talked about better training of the model.
Mhm.
So, how we can train it better? What are the ways to do it?
Yeah, so by training, what I meant is uh, along with like in raw form, what you will do is like you may use mask language modeling or next sentence prediction. So you will hide some of the things and then you are forcing the model that now you predict that. So that is like naive, okay, like you are not giving any instruction. Now, when you really give it an instruction and then say that, yeah, that say this is a paragraph that I am giving you, and I am going to now hide some of the words, and then now what you really need to do is predict those words which I have written. Like this is like an instruction that you are passing. Okay. So with that instruction, model now knows okay that what is the job which is at hand. So like, that's very simple example of saying okay like how can you do the training in a better way. Uh, let's look at another example. So with GPT-4 or like GPT 3.5 Turbo, again a open source like commercial LLM from OpenAI, they trained the model by exposing it to data, but then they brought in the human element as well. They're like, okay, for these questions, these are the answers coming. Now they asked human annotators to rate those answers on a scale of 1 to 5, and then it took an average rating for every question answer pair. And then they included another thing in it called reinforcement learning, where they said, okay, like this is a uh, this is the rating of this answer. This is a good answer which has a rating of 5. Like you can say like the gold standard answer, which has a rating of 5 as per a human being. This is the answer that you as a model generated, which has a rating of 3. Now you try to improve the quality so that that rating goes from 3 to 5. So now you are again passing an instruction to the model. So it's not just with one question answer pair, you will do that with lots of question answer pair. You will give it an answer which has a rating of 5, and then you'll tell that this is the answer that you originally generated which has a rating of 3. Now you keep on generating that answer again and again till that score starts reaching score of 5. So in that way, there is another set of instructions that you are passing to the model so that it tries to get and do the prediction of words or sentences in such a way which would have a high rating from a human being. So that's what I mean by training. Okay, and I think this is what we as educators also do most of the time. That like you look at a coach. Okay, like suppose there's a coach. Most of us would have watched this movie Milkha Singh. So like yeah, like he is able to run say 100 meters in 10 seconds. The coach would not tell that you stop here. The coach would say, okay, now you bring another 0.1 second down, and he will continue doing that exercise without letting the runner know that actually you have broken the national record. That's what coaches do, right? Because so similarly here we are challenging the model that it keeps on improving the rating of its answer.
Hello. Sir, we know that software detects that text has been generated using AI tools. So how software detects that text has been generated and not handwritten?
Yeah, that good, very good question. So see, to answer that, like let me refer to this particular slide. So what these models do is calculate the probability of different words, right? The word which has got the highest probability that got predicted. Now, if we think of a sentence, it is a collection of words. Similarly, if we think of a paragraph, it is a collection of sentences. So now that paragraph or that sentence is coming based on a probability distribution, right? Now the way this probability distribution is getting calculated is from some of the parameter weights. Okay. Now, if say you are generating something using a generative AI model, say GPT 3.5 or GPT 4, those parameters are always the same, right? Whether you rephrase the question in a different way, uh, based on the semantic similarity, based on the semantics of that question, it would give the answer which is nearby, which will be close to the, say, the previous answer. So, and why is it able to do that? Because at the end of the day, those parameters are still the same. The parameters which are helping you predict the probabilities of those words, sentence, and all the paragraphs. So, what these, I think your question is like, how do you detect that it is a generative AI content, generated content? So they look at all those words and then they see that okay, like these words appeared in the generative AI generated content as well, like, and they appeared together. Okay, so based on that, they are able to calculate a similarity score and then arrive at that conclusion that this looks very similar to the answer which was generated by a ChatGPT. So, and there are many tools, okay, which can help you predict that, okay, or know that this is generated by a model, because at the end of the day, the parameters which are being used to predict those probability distributions are the same. So, similar questions would have similar type of answers and similar type of word or sentence formation. So you can just compare that with the GPT generated answer and then say that yeah, it has a 80% probability that it is generated using ChatGPT. But a model like, I think a plagiarization tool which is built to detect whether it is created using ChatGPT may not do a good job when it comes to doing a plagiarization check for some other LLM. Because though that LLM would have different parameters, different training data, so yeah, like these plagiarization tools also would have to keep up with that. Okay, that if a new LLM is coming, they need to factor in that.
Hello, sir. Want to build a domain-specific model by referring the pre-trained LLM model along with I'm going to fine-tune some training model. Now, when I'm going for that one, the corpus is high. Corpus is high. I cannot go for one-hot encoding. Huge number of words are there. So I will go for vector space.
Right.
I want to know, will there be any scope to optimize that vector space? So what the computational burden will be less. That is what the main aim. Will you please throw some light on that?
Yeah. So see, like when we talk about vectorization, so to vectorize we use embeddings model, and depending on which embeddings model you are using, a word may be projected into n dimensions. Okay, like in this picture I showed 3 dimensions. Now, if you are worried about that, yeah, like your vectors should, or your vector database should not be very large, it should be small, okay, so that you can store in, say, your local hard disk. Then you need to pick an embeddings model which will not project every word into very large number of dimensions. So, say in case of a 5 dimension, it will be like there will be some score like 0.1, 0.2, minus 0.1, 0.3, 0.4. So you will get a row like that for every word. But if you will increase the dimensions, depending on using a embeddings model which has higher dimensions, then you have to store larger vectors for every word. So that's where you have to identify, okay, that which embeddings model should you use. I mean, it's a trial and error. Okay, like you start with the smallest embedding model, and you also try with the largest embedding model. If say whatever vectors that you are getting for your data, you are able to store in the limited memory that you have, then you can just go with it, because higher the number of dimensions, the better the accuracy. But if you're not able to store that, then you can start reducing the number of dimensions. So there are different models which are available, some which would have 4096 dimensions, some which have 8192. So accordingly you can pick which embeddings model to use.
Can I able to explore the relationship between, or if I would like to find out, will there be any self similarity amongst within that vector space? So what can I able to explore that orthogonality by using some norms?
Uh, can you give an example? Get your question?
Now, in a vector space, as you talked, like till 5 dimension and 409689 something, means 8000 plus 4000, that sort of dimension is there. Though my corpus is high, for example, kick, if I do take the sports as a domain, KICK kick. Now kick, immediately the next word will come down near about to kick. There may be somebody who kicked the ball. After kick, there may be a ball name, maybe football. It may not be volleyball. Now, that football and kick, now when I am going for that one, football is moving all over the ground, player is also moving all over the ground. But it's not necessary that ball will be always kicked by the player. It may be kicked by somebody else who is standing outside, or like generally we have seen the coach used to kick the ball. So in that case, like there is a similarity of kick. It may have, it is a one word, and there may be the some players, they may be identified as the some another word.
Yeah, I got your question. Okay. So, see, like, I think here similarity is not important, association is important. So, it is thing which is to do with the attention mechanism. So, whether you use 4000 dimensions, whether you use 8000 dimensions, you won't see much of a difference. Because attention is something which is independent of that. When we are saying, okay, like it is able to capture the meaning of the word in the context of the surrounding words, it is creating this type of association map. That this word is associated, has a higher chance of association with this word. Now, now you want to maybe say predict the next word, okay, like that this ball was kicked by, or this ball was hit by someone, okay. No, ball hit someone, like, no, what it will do is it will try to start seeing association of these three words with the other neighboring words that it has seen. No, someone means it has to be player, some player. Okay, so it becomes clear. Okay, because someone would always refer to some person. Okay, now the no similarly all kick, these two things, noun and verb, would also mean that it has to be something has happened. Okay, and there is someone who has done that action. So now it would have seen that, okay, there are name of three players which are mentioned, as well as the referee. Okay, based on that it will calculate the probabilities that whether it should be the referee who picked the ball, or the goalkeeper, or the striker, and then it will predict that word, that whether the ball was kicked by the striker or the goalkeeper or the referee. Now, if you look at these three options, we would see more mention of ball being kicked by the striker, because like even when commentary is happening, the commentator would be saying, okay, like this forward striker hit the ball. That sentence will present many more times than the goalkeeper hitting the ball or than the referee hitting the ball. So based on that, it would predict that the ball has been kicked by the striker. Now that may be true or false. It won't know that. It may be a chance that a referee kicked the ball. But what it will do is, because it saw that the word ball kick appeared more with strikers, it will end up predicting that.
So in that association formation, like I may get the huge list of that association for it is a tree sort of structure. Like if I want to break down that tree structure by identifying some articulation point, and through that one, if I want to optimize that space, from aim is to minimize the computation.
Yeah, so what you're talking about is, see, like, yeah. Yeah. I'll just try to answer that, okay, very quickly. Okay, so I said that this transformer architecture has neural networks and also attention mechanism. So what you really need to go do is you have to really play with the attention mechanism as well as with the neural network here. Then you will be able to really have a control on that. So when people are doing that by changing the architecture, by playing with the architecture, people do that, okay, all the time. For example, if you want to compress the model, people are using techniques like quantization. People are or ruling the model where they will say, okay, like we will drop some of the weights which are close to zero. So we'll just drop those and uh, the number of parameters will go down, and then they will again reevaluate the performance of the model. So you can do all those things, means pruning or quantization. Quantization means 32, rather than representing model in every number with 32 bit, you represent it in 16 bit.
Okay, thank you, sir.
Any other questions?
Sir, as we can see here, you said that means attention is the independent thing that we calculate. But from this architecture, we can see that the multi-head attention is calculated out of the value key and the query matrix. And also, if we see that all these three, like sir was asking about the optimizing the vector space, right? So if means these matrices are also derived from that particular embedding matrix. So how you are saying that this is independent of the attention model?
So see, whether you represent a word in terms of 4,000 numbers or whether you represent in terms of 8,000 numbers, the direction would be the same. The word ball and say the word volleyball, they will appear across the same vector. Whether you project it in 4,000 dimensions or whether you project it in 12,000 dimensions, they will appear in the same direction only, right? So in that way, it does not really make a lot of difference. Of course, yeah, I mean, there is a difference, but in the sense of calculating the similarity of these different words, it does not have a lot of difference because similar words get projected in the same direction, whatever be the number of dimensions.
Like in word, we use word to vec and we use 300 dimensions for each word, right? But if we are using means higher dimension and if you are saying that it is not impacting the sequencing the words will be placed. So means if you are using a 5 or 4,000 word means vector size, so means there will be a lot of padding to be done in that case if the words are smaller in that scenario.
See, padding could be required when the whatever text corpus that you have, it does not have a lot of words, right? So suppose you have only 100 words. Now you want to really project them in 4,000 dimensions. That's not a good way because why do they need 4,000 dimensions? Maybe like 40 dimensions would be good enough. So in that sense, in that type of scenario, you would not really go with 4,000 dimensions. You would go with 40 dimensions. Otherwise, you will end up doing the padding and then just consume the space.
One last question, sir. Is there any way to optimize that, or we can say that any optimized matrix means is there how we can get that?
So optimize what?
Optimized embedding matrix, how we can make that?
So you mean like whether it should be like, let's take an example. So what you're saying is whether it should be 4,000 or
Or it should
8,000.
be 3,000 or something like that. What will be the optimized means how we
You
can
will have to really do a time study, exhaustive study around that. Okay, like with this dimension, you get, and you'll have to pick the dimension and also some objective. And then basis that you'll have to do, because optimization means you want to minimize or maximize something. Suppose you want to minimize a loss function, and that loss function is like the difference between the actual word and the predicted word. First, you have to define your objective. Your objective could be accuracy, your objective could be recall. Based on that, you'll have to then vary these dimensions and see how is that objective behaving, and wherever its minima or maxima comes, based on that you can say that yeah, stop here. But see, like these things you can't do really on pen and paper.
Yeah, right.
Because this is in multi-dimensions. You'll have to do use techniques like gradient descent.
Yeah. Thank you.
If there are no questions, then like I will just cover two more concepts. I think we have 10 more minutes left. So in that demo that I showed, I was saying that yeah, there are three different prompts, like the restrictive prompt, then the relevance, and then the creative. What does prompt really mean? So let me explain that by using some examples. And even before we go and take a look at how a prompt is, let me also define what this different learning, the zero shot, one shot, a few shot learning means. So suppose we are telling LLM to classify this review. I love this movie. You have not given it any prompt. The only thing that you are giving it in the prompt is classify this review. So this is your prompt here. And then it is supposed to predict the sentiment. Now, if you look at this example, here we have given one example. Classify this review, and you are saying the sentiment is positive, and then you are asking it to do it for the next sentence. Right? Here you have given one example. So it's a case of one shot learning. One shot, one example. Now, here you have given two examples. So it's an example of two shot learning, which is also called two shot learning. Okay. So what people what people have observed is the more the number of such prompts that you provide, say if the number of shots become 3, 4 or 5, you will see the prediction that is happening would also, the quality of that prediction would also go up. Let's see an example. So this is a prompt that I'm passing to the model. I'm saying, okay, tell me what word shall come after this sentence, and this is the sentence. What is the right way to design car? Now here it does a decent job, and it says speak generic, right? Zero shot learning. Well, let's try another sentence. Now I'm saying, okay, tell me the right label for this sentence out of these words. I'm saying I have a problem with my iPhone that needs to be resolved as soon as possible. Same model, all the same parameters. What it says phone. Well, that does not make any sense. Neither it brought in the urgency, neither it showed okay there is a problem with the phone. It did not do any such thing. Now we give it some examples, and then we say okay, like for these examples, these are the important words. So I've given it how many shots? 1, 2, 3, 4, 5, 6, and 7. 7 examples, 7 shot learning. Now when I ask the same question, it says iPhone problem and resolve. Right? So now if someone really looks at these three keywords, now they can make some sense. Okay, that yeah, there is a problem with an iPhone that needs to be resolved. Whereas earlier it was just saying phone. So now this is a capability which is exclusive to these large language models, where the way you give the instruction. I think there was also a question like how can we, what do you really mean by instruction? So this is one example, okay, where you are giving an instruction and you are also giving some answers. That this is the correct answer for this instruction, this is the correct answer for this instruction, and now for this instruction, for this sentence, tell me the correct answer. This is a capability exclusive to the large language models. Like you can't really get such things done from a sentiment classifier which is based on a logistic regression. You can't do that, right? But LLMs can do that without writing any code in a human language, human understandable language. If you are passing the instructions along with the right pair of answers, it is able to do that job. So that's what I mean by prompt as well as zero shot or few shot learning. And yeah, I think I'll wrap it up here. So, but before we wrap it up, like just summarize few of the things. So towards the beginning, like we saw a demo on generative AI used for education of the platform Vidya, and how can students have a conversational learning experience. That was to sort of set the context. And then we looked at, okay, what is generative AI? What's really powering generative AI? And that's where I explained about what are large language models, and then I covered about, okay, like what's really powering these large language models. Okay, uh, so what's really powering these large language models is transformers. So tomorrow, if someone asks, okay, what is powering generative AI? What is that is behind generative AI? You can with confidence say transformers. And if you are someone who are from a computer science engineering domain, and someone is expecting a more detailed answer, then you can tell them, okay, that transformers, and depending on the use case, you select the right architecture, whether encoder, decoder, or only encoder, and that will help give you the optimal performance. Then we looked at a bunch of other concepts related to the size of the model, the number of parameters, what's the influence on number of parameters, what is the influence on training, the way you train. Okay, and I also covered something about past language modeling and next sentence prediction. So that's how these language models are able to train or learn language from a large corpus of data using mass language modeling and next sentence prediction. I also explained you one of the most important thing which related to transformers, which is attention. Okay, so when it comes to transformers, of course, mathematical representation of words existed, okay, since 2012-13. But what this transformer really brought in as a new value add is attention mechanism, which was not there earlier. So generative AI, large language models, transformers, then attention, and then all this bunch of concepts. Okay, like parameter size, of number of parameters in the model, how you train the models, uh, and then the last concept about what is a prompt. Okay, and how does a prompt really help. Okay, or how does the prompt really force the model to do a better job. Okay, and well, yeah, this is a very famous tree that, yeah, as the number of parameters are increasing, we will only see that these models from I think very soon may proceed towards artificial general intelligence. Right now we talk about AI, but I think we may enter the area of artificial general intelligence if these models keep on learning better and better with time. I'll stop it here. Uh,
Say, QR code is on the screen. You can scan it and generate your certificate. You can scan from your mobile. You write down your own name.
थोड़ा लैपटॉप का बैग देना
From back side also can be scanned. So that this is attendance for you.
ये लो ना
So I request all the speakers coming on the dais and the coordinators. All of you able to scan? You scan it, fill it, minimum things, and the certificate within seconds will be in your email. Coming. Our kids are playing back behind.
Hello. Hello.
Yeah, you can scan. Those who are not done. So ethical consideration, right? Those who are sitting from morning, they only will be scanning, or only those who are joined just now also scanning.
माझे करने वाले
So our students can help you in case you are not able to do it.
हाँ बोल काय म्हटलं अच्छा ठीक आहे पण तो थांबणार आहे वाटतं. हो. स्कैन करके दो ना हो नहीं रहा है देखो गूगल स्कैन गूगल लेंस से तो क्या मैंने चाहिए गूगल थैंक यू
Yeah, last session of this today will wind up within 10 to 15 minutes. Yeah, so we'll try to wind up at the earliest. If there is any questions and all, we'll take little more. But by 5:30, everybody will be out of this auditorium. Okay, so sorry, and yeah, because we also don't want to come on Saturday, right? But this, when it's supposed to happen, it will happen. So, with the wish and will of blessing of management, we need to do it today itself. Okay, this is the plan. I request Another madam to start with.
Good evening, all. We are in the last leg of the symposium, and after very engaging sessions, I think it's the time to have a quick panel discussion because this very symposium was organized in view of actually integrating AI in our teaching learning from the coming academic session. Many of us are doing something or a bit of AI in our teaching learning. But if we really want to make organized efforts in integration of AI in education, then perhaps there are certain issues and concerns which need to be addressed. And the first one is, and that's why we are going to gather the inputs of all our experts who are already working in the field of AI. So the first concern that I would like our speakers and the panelists to opine about is ethical consideration and privacy concern in AI application for healthcare and education. So I would request the speakers, the panelists to give your quick opinion on this particular issue.
Hello. Yeah. So I will start with this topic. So I think one of the primary ethical consideration which on the healthcare side and the education part is mostly about that how do we prevent the plagiarism? How do we not create the bias into the system? Right. So that if the bias is happening, if we plagiarize and copy paste of some of the things, that may be hurtful for some of the communities. That may be hurtful for the original researcher, right? And if the bias is happening, then basically, with respect to the healthcare, it will be very, very, what can I say, deadly. So when we are thinking about these kind of a thing, I would say that these are the two primary concerns which we have to address.
So, let me add one important area. Uh, so one important area since dealing with data, the data is very sensitive, and be it student data or be it the data that is used to train and all of that, we need to handle this data with utmost care, and the privacy of this data needs to be seriously taken care. So everywhere now India doesn't have a very strong regulations on how we use data, but the moment you take these applications outside of India, such as UK, there are GDPR compliance, there are a lot of other compliance, because what happens if this data gets leaked? Data leak and then it exposes quite a few things and it becomes an issue. So the amount of data that you save, the store, privacy, all security, and what kind of data you store, and how do you process the data is most important. That needs to be taken care of as one of the important.
Uh, as we've already discussed, AI is the newest baby in the medical field. और जैसे we've already discussed कि 5% इनएक्यूरेसी रहेगी सिस्टम में फॉर नाउ. उसके अलावा डेटा बायस भी होता है और उसके अलावा AI हेलुसिनेशन भी होता है, जिसके कारण बहुत सारी गलतियां हो सकती हैं. सो आई थिंक इट्स जस्ट लाइक अ न्यू मेडिसिन. जैसे कभी भी कोई नई मेडिसिन लॉन्च होती है और उसको ह्यूमन ट्रायल्स में लेके जाते हैं, so accountability होती है उस कंपनी की that we are trying this drug on you, and if something goes wrong we will do X Y Z for you, and there has to be a transparency कि we are treating you with this drug, so these could be the side effects and this is what can happen, this is what can happen, and of course we take the whole accountability. So of course once we integrate AI into the medical practice or medical studies, we have to consider these two things. Personally मेरे को ये लगता है accountability होनी चाहिए और transparency जरूर होनी चाहिए. That's what I perceive.
I welcome the views which have been presented by my co-panelists. I would just like to add, as we are talking about AI coming into the ethics and medicine. See, we have already one module which has been given by National Medical Commission, that is ADCOM module. So there E stands for attitude, ET stands for ethics, and COM stands for communication. So there are already some fixed number of competencies. If I am not wrong, 54 competencies are there. which are already enrolled in the medical curriculum for the undergraduate learner for MBBS. There is yet to be an AdCom module designed for the postgraduate course, however. But then, if we are to frame rules or we have to frame code of conduct for this AI coming into the domain of research as well as patient relationship with the doctor's relationship with their peers, all the aspects taken together when we are talking about such domains. So, that domain can be taken as a foundation for the do's and don'ts for ethics. This is also food for thought. Thank you.
So, like if we look at the implementation of these type of systems which will consume healthcare data, I think government has already started acting in that direction. Now I think there is something called Aadhaar number. Okay, I think the full form of which is like Ayushman Bharat. Uh, yeah, health account address, Ayushman Bharat health account address, where what it does is it pulls in your Aadhaar card data or the Aadhaar virtual ID, and then it is able to map your health data to the actual person who has that Aadhaar number. Now, to really make sure that all the privacy and ethical concerns are taken care, uh, what government also came out with is like one act in 2016, like targeted delivery of services related to financial inclusion. So, I think when it comes to healthcare data, the onus is on government, the policymakers, and I think they have started taking some steps in that direction in terms of owning this data in a way such that it is properly guarded. And in fact, for this APA number, uh, it is now being rolled out across hospitals which are run by government, uh, and a lot of hospitals which are run by state and central government. They provide you an option to link your health records with that by creating that APA number. So, to really make sure that privacy and ethical concerns are taken care, government will have to keep coming with new policies, new frameworks, and like as well as keep developing applications to really. Yeah, so government would have to create such frameworks and policies to make sure that all the data remains in secure systems. And as I was mentioning, state and central governments are creating their own applications to store and process the information of patients. And I think yeah, government have to keep doing it, working on that.
Uh, Actually, I was not in the uh, first part of the discussion, but as far as ethics are concerned, the principles remain same. Whether you are doing online, whether you are doing offline, whether you are doing with AI, whether you are doing with any other thing, ethics and morals are two very delicate things. And if we go by Bologna Declaration, which governs the medical ethics principles, more or less those principles will be applicable in any field, whether you talk about behavior of the doctors with the patient or use of AI. It's just the human nature which we are trying to map with into whatever we want to do. Everything will have a flip side, so we have to look at the sides which are brighter, uh, and uh, and we cannot stop because somebody is going to steal something from you. That is why we will not earn is not the correct way of looking at things. So that is my personal view about any ethical issues and ethicalities in any sphere of life. So I think that is what I want to add. Thank you.
Ankita.
Those who are coming just now schools, screen there is a QR code, you generate your own certificate. school people, those who joined just now.
Yeah. So this was about the ethical consideration and privacy concern in AI application for healthcare and education. We heard the views of the panelists, and maybe there is something in the health arena. I am not well versed with the terminologies, but I think there is some oath that is taken. So perhaps something like that can be done when it comes to the application or usage of AI in healthcare in particular. And maybe some such oath can be appropriate for the educationist as well. Because ultimately it is totally dependent upon someone's value system. So even if we do rounds of discussions around the topic, ultimately it will be the part of the value system. But still, there has to be something which someone should feel accountable for, and maybe some kind of undertaking or oath or some kind of what you can say manifesto would be.
Yeah, so a very important aspect of Hippocrates oath, or whenever you practice medicine, ma'am, is that's an underlying thing that do no harm. So we cannot take chances. Even if there is 0.001% chance of doing anything harm, you better don't do it. So when it comes to AI, that application of AI is good enough. We are exploring and it's evolving. But till it is like foolproof, you cannot rely on it. If you're talking about, treatment protocols or completely relying on AI for any particular treatment. So that we cannot do as yet.
So the definition or the scope of your that statement now has included AI as well.
So that's exactly what I said. Just like when a new medicine is launched, and then there's a human trial. So there's a full transparency and there is full accountability on what doctor tells the patient. I'm doing this trial on you. There could be these XYZ side effects, and if the side effects happen, we'll compensate you well in whatever way we can. So as AI, as you said, new और इसमें बहुत सारे variables हैं कि नहीं हो सकता 80% accuracy जो हम maximum देख रहे हैं. I think अगर वो ट्रायल पे लेकर आया जाए with proper transparency and accountability, I don't think there is a harm to it, because unless we do new things, we will not be able to grow. Personally, I feel that.
I want to add one point to what Tripti said and what Sir is saying, that do no harm is all right, but many a times it is done with ignorance, because many a times we are not aware as to what is ethical and what is not ethical. So maybe sensitization onto what is ethical is more important. It might not be an intention of a doctor to do something intentionally in that sense. So that sensitization, that awareness we should have as to what are no's in this spectrum, and maybe university can come up with some guidelines as to what are no's as far as AI is concerned.
Exactly. So that's a good point, sir. So since we are talking about policy, policy is wide area, and everybody wants to have a policy. US is coming up with their own policy to Congress, and we came up with our own policy. We still not done. Every state has their own policy, so it's a wide area. So the best thing would be that since at university level you are going to support development of lot of applications in-house in varied spectrum, complete an AI policy panel which will have a general guidelines and policies of what to use, what not to use at student level, what has to be done, which should consider all ethical consideration, all of that, and to start with, at least people should follow that, and then it will get improved and exceptions will be taken at certain point in time, and that's how I don't think any other universities have already have an AI policy or anything I have heard about follow karega. So don't wait for government to give you a policy. Government few days, few weeks before जब डेटा में थोड़ा वो wrong data आया तो गवर्नमेंट बोला कि everything now you have to come and check with us and do. The next day they retracted saying startups को apply नहीं है. So we know that there will be lapses, there will be issues that will come in these areas, but it should be in a certain level that it should not affect the people. So I hope you understand, right? Even in clinicals, if there are test trials and there are false informations, as you rightly pointed, may come. It should not affect the end user. So how are you going to do such pilots, which are critical, right? Those you need to carve out and have it for separate area. This is applicable. This is not applicable, kind of to start with, and then you can mature it up over a period of time.
Precisely. The very basics for this panel discussion is the same. Why wait for the policies to be formed, and why wait and look at someone else, so that after that only we will, I mean, instead of being reactive, we would like to be proactive here. And that's the reason that we are indulging ourselves into this kind of discussion. So as in the beginning of the panel itself, I said that we definitely intend to integrate AI into our teaching learning from the coming academic session. And that is why you can see the crowd is not 150 that we had decided earlier, but our patron advised us not to go for such a small number, but to make it more inclusive. That's why now we are close to, or I think we have passed the number of 600. So more people are sensitized on this particular domain. It would be better for us to adapt to this upcoming trend. So we definitely do not want to lag behind, but while using it, we also have to see to it that it doesn't backfire on us. And that is the reason why we need to form a policy, guidelines, as you are saying, some kind of a steering committee, so that we really make a conscious usage of this technology, because there is no option than to go for it. So while going for it, why not to go with open mind? And that's the reason why we want that there should be a policy related to the use of AI for faculty as well as students, because then again there are a lot of thought schools about it. Like the students are losing their thinking power, that's fine. So should we accept what the students are giving us when we are asking them to solve their assignments, what they do on ChatGPT and submit to us, whether it should be acceptable or not, synopsis should be acceptable or not. So there are many things. And at the same time, whether a teacher should pick up everything ready-made stuff from the AI tools available. So again, it's a conflict not only for students but also for faculty. So we actually want to find a way around it so that we use it, but still we do not try to cause any kind of harm or making them little lesser competent than they are capable of. So I would like you all to voice your opinions on this. Yeah.
So
Can I
start.
can I add over here? So I joined this panel late, so I don't know if any of this has been discussed, but I can talk in the context of schools. Uh, First of all, defining ethics. If there are 10 people sitting here, how do we define ethics? And if there are 300 people sitting over there, how do we define ethics? Because ethics, generally speaking, has never been a deliberate part of Indian curriculum. If you look at professional courses outside, they have ethics as part of their curriculum, which is given weightage, a very solid weightage, in terms of the final grade that is given to children. I mean, when I was during my undergrad days, I was pursuing two professional courses. I was pursuing Chartered Accountancy course from ICI, and I was pursuing CFA, Chartered Financial Analyst course from CFA Institute US. They had an entire course of ethics. Before doing that program, I didn't even know that you could have a subject on ethics. The other thing about ethics is it is different from your personal moral landscape. So I believe you have 25,000 children in this school, and then you have 1,000 teachers. And I don't, first of all, I don't see children, their teachers, and their parents as part of the conversation anywhere when we talk about policy, especially in India. In India, we do not include them in conversations. If this is the first time that, let's say, an AI symposium, I don't know if you've done similar initiatives in the past, but if this is the first time, are you making space for asking the people who are actually impacted by this inside classroom? Otherwise, you have a lot of people who have opinions about how AI should be used inside classrooms, but those are not the people who are either teaching or they are learning or are getting impacted. But the children's future is getting impacted
a lot of jobs that are going just now, we have to look at the ethical implications in the, what are we teaching in terms of AI? Um, what is the school's set of values to begin with? Because your ethics will be derived from your organizational values. If my organization believes in trust and transparency, if those are two values, how is trust and transparency there in the classroom if tomorrow you decide, I will allow children to use AI? Or you say that now the teachers will create all their questions using AI. If you can create questions using AI, the child can also do that. In fact, children already are doing it, right? What is it if a child cheats? What is that cheating now in the context of AI? How will you define cheating now? If you are giving a homework assignment to a child, what will be acceptable to you now? If a child comes back, have done everything using AI, what will be acceptable to you? What will not be acceptable to you? Who should be making these decisions and who should be having these conversations? So step one when you talk about ethics is to first ask the teachers and the students. I think opinions matter over there. A lot of young children, in fact, even though they are aware of terms like ChatGPT, have a very strong moral this thing. I will not use it if it is cheating. As opposed to if you ask a 10th grader or a 12th grader, we have spoken to several of them, and they are of the view that if I go to school and if I'm not getting adequate support and I keep getting endless homework and endless exams, I don't mind using AI. It reduces my workload. But where is the learning happening there? And again, I will say something which I said back in the school track, that please go back and look at your country's educational framework. The national curriculum framework is now emphasizing that you have to focus on a student's growth, not on marks. So if you are not focusing on marks, how will that conversation around ethics then take place? It's a very vast subject, and when you talk about with the policy, again I'm reiterating because I have a stage here to not directly introduce it to children. Please understand, people who are working on AI technologies are not clear about it. It is called black box for a nature. They are saying they are not, they started off with an intention of creating certain AI models. They are not clear what is happening inside that model and why are certain results being generated. The people who created are not clear. How can we begin a conversation on ethics when we don't even know what AI can do? So those are some of my thoughts.
Uh, Maybe the point is well taken. First of all, secondly, we have to understand the premise why we are discussing ethics. It has a limited scope as far as we are concerned. As far as the policy making is concerned, overall it will be definitely all stakeholders will be involved when we are talking about the policies. I would rather say it is setting ground rules depending upon our curriculum, what are the requirements of the curriculum, rather than going into the larger debate of how we don't have to form the policy for the nation or something like that. We have to set ground rules for our own consumption. That is where the discussion point has started. As far as ethics education is concerned, definitely the Western world has matured more as far as ethics education is concerned, but it is not like that the ethical education is not the part of Indian system of graduate or postgraduate training. As was the discussion which started with the Hippocrates Oath. There itself, I'm talking about, and if you want to have an Indian reference, then there is a Charak Samhita where it is already mentioned as to what are the ethical conducts of a doctor or what are the ethical conducts of a physician, they would at that time would say. So it's like more of a hidden curriculum as far as Indian curriculum is concerned. Over a period of time, what has happened is that we have lost the shin of hidden curriculum in our system. So that is why it has to be made more explicit now. And that effort also UGC and the governing bodies are taking very seriously. I think Medical Commission has come up with, I mean,
fixed credits program as far as the attitude, ethics, and communication is concerned, that is there since 2019. Even the national credit framework, which has been formulated, the basic definition, if you read about it, then there are issues which are not directly addressing ethics, but since I'm working with that skills body, the ethics is very much a part of the whole system. Yes, the maturity level as far as the Western world is concerned is much higher because it is more acceptable. Now, I would say our own example, the ADCOM module, which is attitude, ethics, and communication, is given to medical students last week, and there was and the attendance fell down to 20%. Rather, if I teach them about surgery, the attendance will be 80-85%. So they still don't think as of now, because again, it has not come from within, or it has not come in the culture part as to whether these programs are important for them or they mean there's something for them. Couple of students wrote that these are useless topics. Why are you taking? Why are you wasting our time? So. In a country, democratic country like India, if the policy is to be made thinking about everybody, then it is a very difficult task. We have to create a draft and then take it to the larger audience as to change or modify or do things like that. It becomes very difficult for coming to a consensus in a country like India. We are not South Korea or I mean North Korea rather. Then that we can force anything on our population. So we have to take it with a draft. I totally subscribe to your broader consideration as to whether what is right, what is wrong, what is moral, what is ethical. But here the limited role of this discussion is setting ground rules for, let's say, 2 to 3 years. Of course, uh, every 4 years skill sets change. I am seeing this revolution related to digital technology from YK to what Y2K. Y2K generation. That time also these considerations were there. All these things, what we are discussing now in context of AI, all those discussions in Manali madam would appreciate. 1998, 1999, 2000, we were all mad working on what are ethics, what are going to be the reasons. So the life cycle change, it comes to a full circle. It is nothing new. Revolutionization in next 5 years, it will be another topic like AI, which will have all these discussions, and all of us will be sitting and deciding upon it. So it's not that we can we have to take all the points which you have mentioned very seriously. But if we consider all these points all the while, then we will not come to any conclusions. Is what my feeling is. Thank you.
As of now, we are looking at very broad points. I mean, as to
I
what
just
we
want to
should
add
do.
one line before to what sir said. Fear of something new is very natural, but change is inevitable. We all need to remember that.
Very well summarized by Lalit ji. So the point is that let us not look at the generative AI as a cheating element or something. Now today globally what we are talking is let students use it. Now today all of the educators had a chance to see what all it can do. Now why don't you include it in your teaching and learning, where you say that these are the questions that you should use ChatGPT prompts to generate and give an answer. Tell student this you have to use generative AI. In this scenario, don't use generative AI. So at least they will understand why I should use here, why I should not use here. So give them the flexibility of, if you tell don't use generative AI, I'm going to be looking at all the data that you have copied or not. Let me bring plagiarism checks. You are fearing people, they're going to use it in the back. So let them know in these scenarios you can use. In these scenarios, don't use it better way. So try to do more prompt engineering and how differently you are going to ask generative AI on these questions and scenario. So that will bring closer to what we are talking. And moreover, next time when we sit and discuss, probably we should talk on the policy that you guys already have framed from this discussion. And probably in that exceptions and scenarios, we should talk a progress step forward, right? Rather than what we are.
Yeah, and that is how we are going to find our sweet spot. That's very important. Yeah. Thank you very much. I mean, though I know that this is a very, very broad topic, but then fine, with the limited inputs also, we would like to come out with something black and white before proceeding to formally adopt it as in our teaching learning. Thank you one and all. Thank you very much.
Yeah, last, not the least. So we are not, because of morning time constraint, we are not felicitated our guests. I request all to come forward. I request VC sir to felicitate to all the guests. First, first to the Anupam from Manager. All of you can come friends so that you can come in the photo. So I request VC sir again to give to Devrat Arya. So yeah, I request Provisi sir to give to Sahani sir. Navdeep. Uh, next lead. So I request Vaibhav and Ajinkya and Vaibhav to felicitate to Aslam sir. Vaibhav. Meantime, those who are not generated certificate, QR code is there. You can scan it and generate your own certificate. So those who came join late, you can scan the QR code and generate certificate. Last but not the least, to Ankita, our registrar madam, and as well as both of you. I request all of you stand for national anthem.
तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाए तव जय गाथा, जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे, जय हे, जय हे, जय 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 हे।
IT is arranged outside. Please have it and go. And yes. So let us use AI for next academic year. Thank you very much.
हो माझंही म्हणत आहे टॉपिक